Okay, this is going to be a little video demonstrating the web interface for the ammo can phase angle meter, and this also demonstrates the same feature will be incorporated in the MOT 2022. This will be a software update of the MOT 2019. What it does is it graphs as a storage oscilloscope, it graphs the first few cycles of an instantaneous test so you can check for wave shape, distortion, or DC offset. So I'm going to attempt, I'm doing this by hand, so it may take a couple of tries here. I'm going to attempt to do an instantaneous shot first. Okay, I've accomplished that. To get some button press on the test set here. As you can see, the clearing time was a little long on that particular test. The breaker would have been a little slow had it been an actual breaker. The time was 54 milliseconds, and you can see the oscilloscope display on the left side of the screen. And you can see exactly where the contacts parted. If there was any DC offset, you could also see that. Okay, you can see that it was a 1500 amp test, and you can also see that cycle by cycle. It got the first half cycle on the bottom there. You can see where it says first half cycle was 1497.33. This is within 1% of reading. Cycle 0, Cycle 1, and Cycle 2 are also presented on the instantaneous test data there. So you know the RMS amps for each cycle, and this is within 0.5% of reading. So, you know, it's much more accurate than your 5% of range test set, which will have a 10,000 amp range, so the reading could be plus or minus 500 amps down where you are here. So now I'm going to attempt to do a short time test. You can see this breaker has a short time characteristic. Okay, I managed to do the short time test. You can see I got that one right in the range where it belongs. It's right in the time band where the breaker should have cleared. The peak amps was 700, and you can see it went a little over 6 cycles. And you can see that the instantaneous data for cycle 0, cycle 1, cycle 2 is all listed right there. So you know what the current was during each cycle of the test. The time was also in that instantaneous test data column. The time was 0.134 seconds. And again, you have the first half cycle on there, so you get a useful measurement if the current was on for a half a cycle. I'll now attempt to do the long time test. Which I'll do at 300 amps. I'll clear the data here. Just go from quality to vector on the test set screen to clear the data, or if you're using the gamepad, you can press the start button on the gamepad like it says there on the screen. Okay, let me initiate here. And the current is timing, simulating a long time test. And you can watch as the little blue line climbs the graph there. So you can anticipate when the breaker is supposed to trip. Getting close to the band here. And we'll trip it there. Okay, I've just turned the current off. It stopped at 80.118 seconds, which is just within the band. You can see there on the graph. And that's the result of a long time test. Now, any of these can be shift print screen, and you can incorporate this in your data sheet along with the oscillograph display to present to your customer or your boss, whoever is interested, exactly what the breaker test looked like. In this case, it says like 299.91. The source is a little bit off. It's calibrated to a very precise meter, and it actually is 299.9 if it says that. So that is a overview of testing with either the AmmoCAN meter or the MOT with the latest software. Thank you for watching.